Welcome to Web Handling. My name is Dave Roysum. We continue this series on DFM by discussing the impossible. By that I mean products that are difficult at best or even impossible at worst. So, just what is impossible? Well, it depends on who you ask, because everyone's tolerance for pain differs. However, rather than using opinion, let us use economics. As seen in the figure, the y-axis is the reason for being in business in the first place. Money. More specifically, we will sum the costs of waste, delay, and customer complaints, and so on, as a function of some variable we are studying. On the x-axis, we have the variable we are studying. In this module, that will usually refer to some property of the web or web product. As seen here, the costs increase as we push that variable. The cost curve is concave upward, often going to infinity on one end or the other. In the case given here, the costs go to infinity on the high end. At the low end, we may well find that the costs of waste do not go to zero, because there are other causes, other variables also influencing that waste. In layman's terms, the product goes from merely difficult to economically difficult to economically impossible, finally to physically impossible, as that variable is pushed to larger and larger values. So, let us begin with impossible webs. In fact, we don't even need to do much here, because these concepts were already detailed in module Web201.47b. Recall that certain web properties have a large influence on manufacturability, waste, delay, customer complaints, and so on. You need to know what those properties are and how close to risk you are with your new product. Impossible for winding includes certain web properties, as we just discussed, in conjunction with certain geometrical properties we discuss here. Examples of difficult to impossible to wind rolls include wide rolls due to deflection, large diameter rolls on small diameter cores for many reasons, rolls with a large diameter to width ratio because they might telescope or tip over, webs whose thickness varies across the width, and so on. In addition, we can add large diameter rolls of some stretching webs because the stresses near the core get too high. Finally, we have the challenges of gravity support of heavy rolls. Whether we wind, unwind, or support heavy rolls at the core or the surface, damage will eventually happen if the roll weight gets large enough. Processes and properties are seldom commutative. By that I mean A plus B is not the same as B plus A. More specifically, just being able to make A by itself and B by itself does not mean that you can make A and B at the same time. Early trials may give you plenty of warning of trouble, but only if you pay attention. For example, making one successful roll by no means guarantees commercial success. Even 10 rolls is nowhere near large enough to establish confidence. To establish that a product is commercially a success will require 10 or 1,000 or perhaps even 10,000 rolls. Anything less will not allow you to get a confident value for waste and delay. However, A single troubled roll in a lot of 10 or even 100 should be a red flag for possible chronic troubles after commercialization. Thank you so very much for watching this module in my Plant Practical video series. Stay tuned as we move on to more advanced web handling topics. Let me know if there's something you would especially want to hear about.